Hello. Today we're going to be talking about the spinocerebellar tract, and I'm just going to tell you sort of the basics of it. It can get a little more involved. I could spend hours talking to you about it, but I'm not. I'm just going to give you a little clip about the basics of the spinocerebellar tract. So here we go. Spinocerebellar tract is a tract that carries unconscious proprioception from the joints of our body. And it's known as primarily an ipsilateral tract, and we'll talk about why. It's called spinocerebellar because it starts in the spine and goes up to the cerebellum, right? Pretty cool. And let's see how it works. Let's take, for example, an elbow. And let's say we're talking about a right elbow. We're going to have peripheral nerves that will emanate from the proprioceptors in that elbow, like Golgi tendon organs, muscle spindle cells, what have you. And it will take that information into the spine. So I'm just going to blow it up right here. We're going to look at a transection of the spine right here. Here's the dorsal root ganglia. Yep. And it comes in. And there's actually two different kinds of spinocerebellar tracts. There's one in the back and there's one in the front. So what do we call the one in the back? Dorsal spinocerebellar tract. That's a mouthful. And the one in front will be the ventral spinocerebellar tract. Okay, so we've got one on either side, of course. And here we go. And let's look at what happens. So for example, the right elbow, the proprioception will come in to the back of the spinal cord where sensory always comes in, and then it will ascend up the spinal cord in the dorsal spinocerebellar tract. Now these spinocerebellar tracts are the most lateral tracts in the cord. So as you can see, they're drawn very, very lateral. This one, the dorsal one, comes straight up. So that's going to come in. It's going to go straight up the cord. And then when it gets to the medulla, it's actually going to go from the medulla into the cerebellum. Okay? So in this way, joints on the right side are going to stimulate the ipsilateral cerebellum. It's like the fast track, like the express train, right up from the one side joints right up to that same side cerebellum. So joints on the right stimulate the right cerebellum. Now, let's talk about the ventral spinocerebellar tract. Let me grab another color here. Let's try blue. So let's say we have an ankle down here, and we have all these proprioceptors down at the ankle as well. And that's going to come into the cord. And for this one, I'm just going to still use this little transection. But that's going to come in, dorsal root ganglia. But what it's going to do is it's going to cross over at that cord level in front of the central canal. It will go to the ventral spinocerebellar tract, and it will ascend in the spinal cord contralaterally. So we see it comes in, crosses over, goes up. Now this one goes up to the midbrain and goes into the opposite cerebellum. But wait, there's more. That's actually the end of the spinocerebellar tract. But what happens from the cerebellum is this stimulation actually is sent. I'm going to show a dotted line to the other side of the cerebellum. So the left cerebellum gets that stimulation, but it takes it and sends it over in the cerebellum itself to the other side. So that's why you see this dotted line. It's not going through the midbrain, it's behind it, right? Because the cerebellum is behind the brainstem. So ultimately, look at this. Ultimately, we talk about the spinocerebellar tract, whether it's ventral or dorsal, as creating ipsilateral stimulation, because ultimately that's where it all ends up. Okay? Ipsilaterally. Now, again, we're done with spinocerebellar tract, but we're not done with its effects. So what happens from here? From here, another neuronal pathway takes this same stimulation, sends it over to the contralateral midbrain. So from the right cerebellum to the left midbrain, and then from the left midbrain to the left frontal lobe. So look at this. Ultimately, what happens when you have a subluxation or you have an adjustment to joints on one side of the body? For this example, the right side. Those joints will affect primarily, mostly, the ipsilateral cerebellum and the contralateral cortex. Okay? So when you have subluxations, what does it affect? Ipsilateral cerebellum, contralateral cortex. When you adjust a patient, what does it affect? Ipsilateral cerebellum, contralateral cortex. Just want to remind you, this is a tiny snippet, and it's sort of a watering down and just sort of a summary of this spinocerebellar tract for our Intro to Functional Neurology course. This is bottom line, basically what I want you to know at this level of training. As you go on and learn more, we've got more to teach you about this, but if you know this, super cool. All right, spinocerebellar tract, there you go.